Hello and thank you for considering Brokk. Today we're going to talk about the Brokk Power Rankings, how we make use of them, and how we inform decisions in the Brokk coding tool using the Brokk Power Ranking data. The Power Ranking was originally created not only to talk about models, but to inform our users as well as ourselves what the best model or set of models is to use for development and coding within Brokk. The Brokk Power Ranking was designed to solve a specific problem. When any LLM vendor releases their models, they're going to cherry pick the benchmarks that make them look good. In fact, most of the coding benchmarks, I would say at least all the common coding benchmarks, have been around so long, they've basically been memorized at this point. If we have a look at some of these benchmarks, you can clearly see with Kimi K2 thinking, at least on Live Code Bench, it shows them scoring on par with Claude Sonnet and coming very close to GPT-5. Also, with Minimax M2, shows benchmarks illustrating them being clearly in the same line with models like Anthropic and OpenAI. If you test them against problems that they haven't seen before, you get what we see in our benchmark, the Brokk Power Ranking. Our testing shows that K2 and M2 produce results that rank them as some of the worst models out there in terms of actual real-world performance for coding tasks. This presented us with an interesting problem to solve, which was that nobody knows, based off these memorized benchmarks, what models are actually good at writing code. When you're building and selling a coding harness, this is critical missing information. Let's just say we accept these as legitimate results. The reality is they only give you a single number. This is not a well-rounded vantage point, and in most cases, when you're making a critical tooling purchase decision, you want more than one data point to inform that decision. When using a development resource such as an LLM in your daily workflow, it becomes imperative to know things like how well does that LLM perform at successfully completing tasks? How much does it cost on a per task basis? And how fast is it able to solve the problems that you're tossing at it on a regular basis? To make informed decisions around how one might use an LLM for dev work, and more importantly for us, how to offer this in Brokk, let's walk through the thinking behind why we decide to leverage certain LLMs for various tasks that make up a development session using Brokk. To illustrate this, let's go ahead and have a look at our big frontier models. So we'll scroll back up here to the performance scores. I'm going to clear all that, and then we'll select the big top frontier models to do a side-by-side comparison. So we'll select Claude 4.5 Opus, GPT 5.1, and let's toss in Gemini 3 Pro. So let's dig into these, and we'll do a score versus affordability versus speed comparison. So as you can see, the Claude 3 Opus is very fast, scores very high on its ability and its thinking score, but it's not really great in the affordability category. So if you were to add in, say, GPT 5.1, you can see that it's on par performance-wise. It's a little slower, and it's a bit more affordable. But let's go ahead and take a look at Gemini 3 Pro. And you can see that Gemini 3 is, while also on par with performance, it's slower and quite a bit more expensive. Given all of this, we picked Claude 4.5 Opus as default because in general, for planning, coding, and answering questions, it is the clear leader. And because professional development generally leans in favor of time-sensitive versus cost-sensitive, Opus becomes the right fit for the job. Now let's have a look at our smaller model comparison. To begin with, we'll go ahead and deselect the current models we have, and then we're going to add in Grok Code Fast and GPT-5 Mini. We'll crack those open and look at the score, affordability, and speed metrics. And as you can see, GPT-5 Mini is very affordable, it's relatively fast, and it has a pretty good thinking score. When we stack on top of that Grok Code Fast, let's see, Grok Code Fast 1, you can see that it slightly edges it out in the speed category. And it is for this reason that we opted to choose this for our free tier model. Let's have a look at what we chose for task implementation. We'll deselect these two models and we're going to add in Claude 4.5, Haiku, and because we don't yet have the Flash preview for Gemini 3 Flash enabled in the BPR rankings, I'm going to go ahead and just talk through this a little bit. So you can see here with Haiku that this was our previous model when it came to task implementations. Very good on affordability, exceptionally fast for task implementation, and it has a relatively low thinking score, which is not necessarily needed for things like task implementation, which is why it was our previous go-to model when it came to just implementation of thinking tasks. We ran a ad hoc test of the Gemini 3 Flash preview during, I think, late December, and what it told us is that the Gemini 3 Flash preview is now outperforming our previous pick, Haiku, by almost a full 15 points faster. So for those reasons, we've moved to using Gemini 3 Flash as our task implementation default choice within the Brokk editor. It's probably at this point you might be asking yourself, this is all interesting information, but now that I know it, what can I do with it? This is where the Brokk tool comes in handy. Let's have a look at how we make good use of this data inside the Brokk editor. An important but often overlooked reality of working with an LLM centers around context and token usage while working through a problem. As context grows, you need to take into account how quickly does the performance degrade, how quickly does the model get distracted, and at what point does the model lose the ability to think accurately about the problem. In Brokk, we give you two models that you have control over. The primary model, seen here, which is used for planning, coding simple tasks, and answering questions. The secondary option, as seen here, which we call Lut's code model, which is used for task implementation, so writing the actual code. And we'll talk a little bit more about what Lut's mode is here in just a bit. Now, you would think based off of what we have reviewed so far that the assumption would be just use Opus for everything because it sits at the top, right? Well, let's think through this and consider what that actually looks like. We're going to go ahead and switch back over to the Brokk Power Rankings here, and we will unload Haiku and reload our Opus model. The flaw in this thinking is that while Opus is at the top of intelligence and speed, it is also at the bottom of the range for affordability. It's fast and smart, but it's very expensive. Let's pull in a model like Haiku. The conclusion we came to is that often you can use a model that is a little bit less smart, but a lot faster on problems that don't need quite as much intelligence. And it is, as you can see, exceptionally affordable. And recall that Gemini 3 Flash, which I touched on previously, is on par with Haiku, but faster. So for Brokk, our current choices are Opus for the heavy lifting and Gemini 3 Flash for implementation. One important note here is that as new models are released and we run them through our benchmark, our default choices will be updated so that we can give you the best models for the job. Heading back over to Brokk, let's take a look briefly at how we integrated the Brokk Power Rankings into the editor and the controls we set up so that you can pick your own adventure. The first stop is looking at our default models and how these models are configurable inside the settings panel within the Brokk interface. So if we're going to go to File, Settings, Advanced Models, Model Roles, and as you can see here we can set the primary model and what we call the Lutz coding model. The primary model being responsible for planning, coding simple tasks, and answering questions, and then the Lutz model being responsible for implementation of tasks. You can also reset to the default values here by clicking Defaults, OK, click Apply and OK, and then that'll set back to your primary models here in the main user interface panel. Earlier I said we would come back to Lutz mode, which is our default agent for coding tasks. Loots is capable of breaking down your problems into subtasks to make them more manageable. The reason this is needed is because as a problem gets larger, the model gets worse. Loots will break down the tasks so that they are the right size for the model to be able to tackle them effectively. Here, we show you the LLM's performance degradation based on benchmark data for that model's performance across your effective token range, which is clearly visible here in our context panel. To illustrate this, let's have a look at two things: how you might manage the context in Brokk and how data from the power ranking can be interpreted to make a logical decision when right-sizing your context. This pulls directly from our power ranking data. To show this, let's load up our two default models on the power ranking site. So we'll go ahead and close this out, and then I'm going to go ahead and add in Claude Haiku, and then we'll scroll all the way to the bottom here, and we're going to look at best scores by task length. Now, why this is important is if you look at something that has a task length or with a number of tokens that's very small, they're pretty much neck and neck at this point. But as you add in more tokens, you can see that Opus starts to gain a considerable lead over Haiku. And this data is used inside the Brokk user interface to reflect this particular setting, depending on the amount of context that's currently sitting inside your context window. Given this clear illustration of how our two default models perform, we can now go back into Brokk and we can pare down the current context to bring it back into a comfortable range for the LLM to work the problem. Now, I went ahead and loaded up a significant amount of context, which is currently sitting at around north of 138,000 tokens. This is pretty significantly out of range for this LLM, as is referenced by the red border around here that says, warning, you're beyond the tested range, as well as you can see the Brokk Power Ranking is rating this at a 54% success rate. So let's see what we can do to sort this out. To achieve this, it's relatively simple. You can go in and you can go by, file by file, and you can delete them out using the little X control here, or you could just grab an entire chunk of context out and basically just drop these 71 files. And that'll bring it back into a range that, as you can see, is now comfortable for Opus to run. And I would almost wager that Flash is also in the same category. So there we go. We've now brought our context very quickly back into a comfortable range for the LLM to work the problem. Now you know the basics of the Brokk Power Ranking, which was designed from the ground up to cut through the noise of memorized benchmarks and provide you with a well-rounded vantage point for your development decisions. By integrating this real-world data directly into the Brokk editor, we empower you to choose the best models for the job. Whether you need the intelligence of Claude 4.5 Opus for planning or the incredible speed of Gemini 3 Flash for task implementation, our goal is to ensure that as models evolve, your coding harness stays ahead of the curve, giving you the most effective tools for every single session. Ready to experience data-driven coding? Download Brokk and give it a test today.